let's start our session. Oh, I called it CP instead of CPP. I have to fix that. Okay. All right. So let's take a look at what we've done last time very quickly. We talked about rule of 5. Let me just bring them up and wow, talked about lots of things. Okay, we talked about rule of 5. We talked about the structures, how you always have to supposed to have the structures and they're supposed to be virtual. You set it to default. We talked about aggregate initialization, which you put curly brackets in front of anything and they can get initialized. You can initialize stuff with, so it's a universal way of initializing everything. We talked about range-based for loops, and we said when you are actually writing a for loop, you can create a reference and set. Let me bring it up because that I cannot explain that. Range-based. I can't see it. Can you believe it? Yeah. There we go. Okay. Thank you. So we talked about range-based for loops, and we said you can actually put a reference in front of a container. Soon you're going to understand what a container is. But the simplest container is an array. We're going to learn many different types of them. And you can that reference that you have at the beginning of the for loop becomes the reference of each element one by one until it traverses through the entire container. Okay? Make sure you have that one as a reference. If you have a reference, you can actually modify it. You can choose not to have a reference and create a copy. So the elements over here, the values that are being set, if you change those values, it will not change the values of the array. So it becomes a copy of each element. In case you do not want to change the values and you just want to read and process something without changing it, make sure it's not that one. And you can always use auto if you don't know what the type of the container is. We talked about nameless structures where you can actually have structures that they don't have a name. If you want to just package stuff without recreating the structures and classes again, you can simply create it and use it in your application. We talked about using the same piece of memory, the same location of memory for several different types if we need to. And that's happening in a union. So union, always the attributes of a union allocate the same place in memory. They overwrite each other. If you choose one of them at a time, or if you want to break some value into pieces, it's a good thing to do. So you can put a double and an array of 8 characters in a union. Then you can actually see how a double is broken down into 8 bytes. And investigate it, for example, something like that. So that's union. Unions are exactly like structures. You can have it nameless. It doesn't make any difference if you need to. We talked about alignment of the union and size of union. It usually it is minimum the size of the biggest thing that you have in a union. So if you have a double and a character, the size of the union is the size of a double, or more if it needs to. It cannot be smaller than the biggest size of the attribute that it has. We talked about pointers to references to pointers. We said pointers are just variables. You put a reference beside it. You're giving a pointer a new name, hence you can change the name. And then we came back to C++, and we said that we came back to C, and we said if you want to change the value of a pointer using the address of it, naturally you need to create a pointer to a pointer, and therefore 2 asterisks. Don't be scared. It's just the address of a pointer, and you can keep going higher and higher, which we don't want to. Okay? I'm never going to ask you. I'll give you a walkthrough with a pointer to a pointer to a pointer. It's just crazy. I'm not going to do that, but it's possible. I strongly suggest get that 4-colored pen and actually write the code and do it. Create a pointer to a pointer to a pointer, and then walk through it and see what happens. Walk through it, really. It's good for your health. Next, we said because of that fact, now we know that the syntax, the real syntax of main, is actually a pointer to a pointer. Because we were scared of it, we put the square bracket in the second one, so people say it's an array of. It's an array of arrays. It's a pointer to strings, but essentially it's a pointer to pointer. It doesn't make any difference. Okay, and the same thing for the environment. The meanings are the same. We talked about inclusion polymorphism, and we said that when you have an interface and you create children for the interface, when the time comes and your interface is actually pointing to several different objects of its own type, copying it becomes impossible because the interface doesn't know what it's holding. It's the inclusion polymorphism that dictates what is running. For that, it's a good practice that in your interface you create a method called clone as a pure virtual function and implement it in a children, so when copying is needed, you can call the clone to copy the values, copy the instances pointed by an interface. And I explained one good reason to use autos is when you are having nameless classes and structures. When you have a nameless classes and a structure and you want to return this, you don't know what is the name of the class. Therefore, you need to have auto to actually identify what you're getting into. We good? All right. And that was the last thing we talked about. Now let's see what comes next. Questions? Suggestions? Objections? They're okay? All right. So I'm going to bring a few things to today's class. Yeah, these are the things we want. Okay, before we continue, because if I lose track of time, we won't be able to do the quiz, and we need to do the quiz at latest 12:40. Wow, we don't have all, we almost have 19 minutes. I don't think I can cover anything there, but I'll do my best. Set an alarm for 12:30. For those who just got in, please log into the subject using Microsoft Edge and using the address of my apps.senecapolytechnic.ca. Run Notepad++ and be ready for your quiz. So when I start, you are ready. So expressions. I'm not going to teach expressions, I told you. You have to read it yourself. I'll bring it up. So copy. So what you need to do is to go to subject notes. That is kind of slow today. Something's happening with the, wait for it to come up. So I want the expressions to come up to just clarify something, the L value and R value that we were talking about. Let's see if it's going to come up. There we go. So I talked about L value and an R value. Now, this is the only thing that I'm going to talk about and show you the example for it. And then you study the expressions, and the next time you're coming, we're going to go after this. So read the expressions. If you have any questions about it, ask me. So we said we have L value and we have R value, okay? So essentially, they categorize any expression that you have into two different things, a GL value and an R value. GL value is a generalized left value, and R value is, okay, something that stands at right side. But so these break down into three things. L values are the ones that can only be, that can be at left side and right side of an operation. There's no problem with it. X values should be at right side, but if they are at left side, they will still work, but I don't know why we would do that. So it is possible, usually logically, you don't need to do that. PR values are pure right values, literal values that they don't occupy any space in memory. Like you put I is equal to 10. If you do that, that 10 doesn't occupy any piece of memory anywhere. It's what we call, it's going to be in what they call it a literal pool. When compiler compiles it, it creates a literal pool and puts all the literal values over there. So if you use 10 somewhere else, it's going to reuse that. It's not addressable. It's nowhere in memory. It's just being used as literal values. Now, X values are supposed to be at right side close to PR values. These are values that are about to get expired. Okay. Because of that, this code was written and to explain what they are. So I created that name thingy that we had up there with all the move operations. Did I put move operations here? Yeah, with all the move operations and things like that. And then I give you examples over here of what it is. So when we come down over here, so these are the move operations that we have done. Ref, no use for now. I'll explain later on what ref is. There is no way for me to give you an example of refs because we don't know how to bind functions. We don't know how to do threading. We don't know how, we'll come to it at the end of the semester. Then you're going to know what ref is. For now, if you're writing B is equal reference of B, duh, B is a reference. Like it doesn't do anything. And you cannot get a reference out of an expired value because it's expired. You cannot convert it to a. So you'll find out when the time comes what is it used for. So x values are, for example, functions that return something by value. You see that? That creates an expiring value because to return the local value, it needs to create a temporary nameless object, copy it into and return it so it can destroy n without destroying the return value. That temporary nameless that is being returned is an expired value. That's something that should be moved. And when you are doing like that, move assignment will be called automatic for it because it's an lvalue reference that is being passed. Obviously, you can always put an expired value at right side of an operation. I'm going to say name whatever is equal to C. It is an expiring value. It's a nameless object that is getting created. And it's just about to die. Why would I do that? Compiler wouldn't complain because when the line is getting executed, this value exists. So that's a correct, not a correct, it's a valid C instruction. It still gets the C and copies it whatever it's supposed to. And then it dies after the semicolon. It is an expiring value. So expired values can be at left, but you always need to ask why. We need to understand it doesn't make sense. So when we are professional enough to understand when we need it, then you can do it. And that's that. So that's the thing I wanted to tell you. So x values can be at left and right. When they are at left, you have to always question why would I do that. OK? And that's it. So remember, L values, x values, and pure right values, PR values. These are the three main things you need to consider. OK? That's that. Please study expressions and come to class with questions. .cpp. Okay? Next. So in OOP345, we learned how to create function templates. Say I want to swap two values, and I want the swapping not to write the same procedure over and over. I can create a template and ask the compiler to create the function for me on demand if it's ever being used. And because the signature of functions dictate how the functions are called, compiler can actually detect it. So when I actually say over here, swap two integers for me, or two characters over here for me, is it two doubles? It's two doubles. Damn. Yeah, so if this wasn't here, like that. So when I say swap two doubles for me, it sees that the signature matches the template. Therefore, it generates the function for you. And you have your function, and life is beautiful. OK? But overloading always supersedes the template, which means if I overload the exact same template with a specific type, when that overload is called, it's going to ignore the template because when it wants to generate it, it sees it already exists. Then why do I generate it? It is there. Therefore, overloads always is a way to specialize logic of a template, function template, when you don't need it. to be done that way for that type. So if doubles are supposed to be done differently, I can overload it. But that defies the whole purpose of why we write templates. We write templates because we don't want our source code contain executable instructions for a function I may not use. Templates are there so when you call it, the function is generated for you. If you don't call it, you're not going to have that function in your executable. The code is not generated. So that defies the purpose. That brings us to function specialization. That brings us to function template specialization, which essentially means this. So I have, let me just, so this is my, so this is my template. I want to find the largest between two objects. And I'm saying return if A is greater than B, A, otherwise return B. So I pick the largest. I return a copy of the largest of the two. Does that make sense? Now, if I want to apply that, so this would work. This would work if I have something like double L is equal to largest of 2.3 and 5.5, 50.5, right? So what happens is that it comes over here and generates that for me, and therefore L will be 50.5. Are we okay with this? Problem is that I cannot apply that to a container. If I actually have a container and I want to do the same thing, it's not going to work because two containers cannot be, right? Immediately I would say, so I overloaded. So we can actually write container largest, container A, container B, and say return if A dot has more. So instead of this, use has more in here and do the same. Are we good? But we don't want that because then that function will exist in my executable no matter what. So what you can do over here is to specialize this template by saying, hey, if I want to have a container, I want still the largest thing to be there. So you said this is a template, but I'm not going to give you a type name because it's special for one type. What is that type? Container. Okay? And in here, I'm going to say, whoa. Oh, shoot. Okay, that's the error messages for templates. So dot, in here, I'm going to say has more. Now it will be okay, right? Problem is that it cannot detect, because it doesn't have that type thingy over here, it doesn't know what to replace. So I have to somehow mark this specialization and tell to the compiler, hey, if somebody wants to create the largest using the type container, use this one. How do we do that? We actually put the tag here. Done. Now, if largest has container, this is the one that's going to get picked up for it. This is called function specialization. For example, if I want to pick the biggest of two C strings, then I have to do this. Then I have to say I have a template again. It's largest for a constant character pointer. And when the constant character pointer A and B is passed, string compare the two and then return the address of the first one or the second one based on what is received. So if it's a string, this is going to be being passed. You understand what happened? So you specifically mention what the largest type is going to be. This is called function specialization. And I think I'm going to tell you one more thing, and then we're going to continue it the next day, because we are starting our test in 10 minutes. Let's see, or maybe 2 more things, or 3. I don't know. Let's see what we can do. So sometimes you have a scenario that your template can be used. You know how to do it, but the compiler doesn't. Remember that largest thingy has T and T over here as types? Now, down here, I have integer A, B, and double C. I want the largest to find out the largest between B and C. But the problem I have is that this is double. It doesn't know how to match the signature. We know that if it was a regular function, compiler would have upcasted the B to a double, right? So I can request it. I can say, hey, for this, I know you cannot find it. Use the double one. And it's done. So essentially, it generates the double, and because it's an integer, it will be upcasted to a double. Or if you want to downcast it to an integer, you can. You can say, hey, if the 2 mixes like that comes, use the int for this. Which means now it downcasts C to an integer and passes it up and return. So you can choose which specialization to get created for you. So you can manually decide what to call when it's not clear. Okay? So that's called resolving function template calls. So a question in the quiz is going to be like this. Explain what's going to happen if I do this. So for the first one, you have to explain the largest will be created with an integer. B is going to be passed as is, and C is going to be downcasted to an integer, and the value integer is returned sits on A. For this one, you have to explain B is going to be upcasted to a double. The 2 are going to get compared. A double is going to get returned, which is going to get downcasted to an integer, put it in A. So you have to explain this. Okay? Make sure you have everything. We're going to start in 5 minutes. Yeah, if you want to go freshen up, go do it now. And we stop right here. Yeah, so and that's it. Close it. Save. commit and push.